Hi, today we are going to be studying the WJEC AS Unit 2 new spec, Mechanics Vectors. Below you can see a typical vectors question that you can expect to see, worth 7 marks. So let's have a read. Two forces F and G acting on an object are such that F equals I minus 8j and G equals 3I plus 11j. We are then told that the object has a mass of 3 kg. We are now asked to find the magnitude and direction of the acceleration of the object. Now, because we are talking about finding the acceleration and we have a value for the mass, we should be thinking about using Newton's second law of motion, which I'm now going to write down, which is F equals ma. From this, we are trying to work out the acceleration, which I'll put as a question mark because we don't know it yet. We know the mass, which is 3 kg. The resultant force we also need to work out. So this is the resultant force, which I'll put here. So we have been told the two forces in component vector form of F and G. The first step that we need to do is find the resultant vector force. We denote this using R, as seen here. We can find the resultant vector force by adding the two forces F and G together, which I'm now going to show. So R equals F plus G. Now I'm going to write the two vector components down, starting with F, where F is I minus 8j plus 3I plus 11j. We're now going to add like terms, starting with I. So that would lead us to 4I minus 8 plus 11 plus 3j, which is R, the resultant vector force in the component form. We can represent this as follows. I'm going to show this now. Let's say we have the origin here, calling this O. 4I is in the horizontal component form, so it'll be this way. So we will have, so that's the 4I plus 3j. Here, which represents the vertical component form. We are trying to find now the resultant force, this one here. Notice we have set up a right angled triangle, therefore we can find this value R using Pythagoras Theorem, which I'm now going to do. We know from Pythagoras that R in this case would equal 4 squared plus 3 squared and the square root of that, which would lead us to root 25, which would then be 5. And now, as this is the resultant force, 5 newtons. We have now found the resultant force, F. We can now find the direction of the acceleration of the object from this same diagram here. This will be the angle theta. we can find this angle using the tan rule. I'm now going to do that. So tan of theta is opposite over adjacent. So that would be 3/4. Therefore, theta would be the inverse tan of 3/4. Which leads us to an angle of 36.9 degrees to 3 significant figures. We have now found the direction of the acceleration of the object. We now need to find the magnitude of the acceleration. We can now use F equals ma because we know F and we already know m from the question. So F equals ma. So we know F was 5 from here. Mass is 3. We want to find the acceleration. Therefore, the acceleration would be 5/3. You can leave it as a fraction or convert into decimal form, which is what I'm going to do now. That gives us an answer of 1.67 meters second minus 2. Meters second minus 2. So we have now found the magnitude of the acceleration of the object. So we have found what the question was asking for. So here is the direction of this acceleration of the object, and what I've just worked out now, the magnitude of the acceleration of the object. So that's 7 marks. And that's how you solve a vectors question of this type. Follow these exact same steps, you will never go wrong and get all the marks. So I hope that was helpful. Make sure that you like and subscribe so that you are notified about my latest videos. Other than that, I hope that was helpful and have a nice day.